So in this video, we're going to talk about finding sample sizes with the population standard deviation. So often in statistics, we want to make sure we collect enough data in order to use our analysis. With confidence intervals, we can use a desired margin of error, population standard deviation, and critical values to determine sample sizes. And here's the formula. So remember, lowercase n represents sample sizes. So sample sizes equal the critical value times the population standard deviation divided by the margin of error, and I'm going to take all that and square it. So let me give you an example of critical values. So if I have a confidence level of 0.90, the critical value is 0.165, and it has to do with the inverse norm function that we did back in Module 2. Here's a list of them that you might need when we start doing this. So again, they're in the PowerPoint if you need to refer to them. So for a 90% confidence level, the critical value is 1.65. For 95%, it's 1.96. For 99, it's 2.258. So let's do an example. When we're given the desired margin of error of 1, population standard deviation of 2, and a confidence level of 95%, we can estimate the sample size. If n, when you do this, is not a whole number, always round up. Think of it as I can't have 15.36 people, but I can have either 15 people or 16. So usually in statistics, we round up because we want to make sure that we have enough in our sample size to do the right kind of calculations we need. So again, I have the formula here. And what all I've done is I've just plugged stuff in. So n equals 1.96. Miss Pace, where'd you get that 1.96? I got that from the table that was on the previous slide. So I looked it up because it was a 95% level of confidence, and I got 1.96 times 2, which was the population standard deviation, divided by 1, which was the desired margin of error. And then I square that and I get 15.36. So again, because that's a decimal, I'm going to round up to 16. So for this analysis, I need at least a sample size of 16. All right, so let's do this next one. Suppose scores on an exam in statistics are normally distributed with an unknown population mean and a population standard deviation of 3 points. How many scores would the professor need so that the 90% confidence level would have a margin of error of 0.5 points? All right. I'm not given a lot, but everything I'm given I can use. So I have a population standard deviation of 3 points. I have a confidence level of 90, and I have a margin of error of 0.5. So again, all I have to do is use the formula. So n equals 1.65. That 1.65 is 90% level of confidence. I'm not sure if people are realizing this, but as your confidence levels go up, your critical values go up because this is 90%. It's a lower critical level and it's 1.65. So my population standard deviation was 3 points. So I put times 3 and I divide it all over 0.5 because that was my margin of error. And then I square it. So my answer is 98.01. And let's talk about it again. 0.01 is a decimal, and I don't want to have any decimals, so I'm going to round up. And I know it goes against the rounding rules, but think about it this way. I want to collect as much data as I can so my results are valid. It never hurts to overestimate your sample size. It never, because you might have people drop out for a number of reasons or whatever. Always get a larger sample size so that you don't have to go back and keep getting data. So again, for this one, I'm going to have a sample size of 99. So let's do, here's another one. Example 3. I'm given sample data, and I haven't seen that before. So what do I need to do? Okay, this is like the other one we did in Z interval. Suppose scores on pop quizzes and statistics are normally distributed with an unknown population mean and a population standard deviation of 2 points. Here's a random score of 22 scores that's taken. How many scores would I need so that the 90% confidence level would have a margin error of 0.25? Well, I'm glad that I have the sample data, but that's not what these questions are asking. These questions are different. Even though I have a sample, I want to know if my sample is large enough. So again, I have a population standard deviation of 2 points. I have a 90% confidence level, and I have 0.25 as my points. So again, I'm just going to use my score. So I have 1.65 times 2, because remember that 1.65 comes from that 90% level of confidence. 2 is my population standard deviation, and 0.25 is my margin of error. I get 174.24. So I need at least a sample size of 175. You could still do the problem like we did in Z interval and get results. But if I want to do something that I've never seen before, I really need a sample size of 175. And it's because that margin of error is really, really low, and I want to be very precise.